All right, we are going to look at sets, and then at grade 9 we did look at the notations and the symbols. Let's just recap, because this time we are going to be actually on sets and basically on shading. Now, the first thing that we could just recap on, it's this, all right, which is actually intersection. Intersection. Now, uh, what does intersection mean? We say A intersect B. Let's just show it quickly by shading. Intersection actually means you have two sets, they overlap, and intersection actually we talk of the elements here. All right? That means elements which appear in both sets, set A and set B, right? That's the intersection, right? Now, we did look at union. No, not like this. It's not a U, right? It's a sign. It looks like this, not a U, okay? Union. So it's the union. All right. Now, how does the union of two sets A and B look like? It looks like this. Say we have, let's make them still overlapping. It doesn't matter. Then the union, we talk of elements in this region. Right? That's the union of the set. That means the elements which appear in both sets, all of them, union, right? Now, also we did come across this one, and we said it's a subset of, is a subset of. All right. Now, it's a subset of. Now, you may have A is a subset of B, all right? So what did we say it means? Uh, uh, this A is a subset of B, and we could say B is not a subset of A. A is a subset of B. B is not a subset of A. All right. So remember, you can put this in bracket. Now, if we say A is the subset of B, what we have is this. We have this set B, but inside this set B, we have another set A. The whole of set A is found in set B. So A is the subset of B. All right. Now, we talked about this. We talked about this. Let me just have this line here. We talked about this sign, and we said this one is a member of. Is a member of. If you don't want to say it's a member of, you can say it's an element of. Now, let's see. Or you can say belongs to. Belongs to. All right. Now, we could have B belongs to, all right, B belongs to A. What does that mean? That means actually We could have set A like this. Now inside set A, let's say we have A, B, C, D. So because this element is a member of set A, then you can say B is an element of set A, right? Now let's see. We did discover that there is this symbol which stands for universal set. Universal set. It's a universal set. Now, um, 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 we could write the universal set as this set of say A, B, C, D, all right, and what? And E. Okay. Now, what does that mean? It means that now, as a Venn diagram, remember these are Venn diagrams, okay? These are Venn diagrams. This we did talk about Venn diagrams in grade 8, all right? Now, uh, um, uh, as a Venn diagram, you could just draw this set, the universal set, as a rectangle, and you label it universal set, right? Now, what happens? We could have a certain set inside here, no problem. Let's say that set had the elements CD. Then universal set would still contain A, B, E. All right. So that means the universal set is the set of all the sets. There might be sets appearing inside the universal set. Okay. But the elements which do not appear in those sets will just be put inside the universal set around those sets, right? So it's the set of universal. It encompasses all the elements. Now, we did talk about this. We did talk about the complement of a set. Let's say A complement, all right? Complement of A, complement of set A. So these are elements outside set A, okay? Not in A. In other words, A complement means not in A, all right? Not in A. Now let's show this. Let's say we have our universal set. Then we have set A in here, right? Okay. So A complement would be outside A. So that means A complement would be elements that are found here. Oops. Okay. Outside. All right. Let me remove this part here. It's out. Okay. It's elements outside set A. Right. Now, then we talked about number of elements in set A. Okay, number of elements in set A. This it means number of elements in set A. All right. Now, number of elements in set A looks thus. So here we are going to count the elements. All right. Let's have this. Let's say we have a set A and it has uh, PQR, PQRS. Okay. So number of elements in it, there are elements PQRS in A. But now number of elements in set A is equal to, we counted them, 1, 2, 3, 4 elements. So number of elements set A is 4. All right, now having said this, we could just remember that we have this sign, an empty set, or sometimes it's drawn like this. This is just an empty set. So if there are no elements in a set, we could say set A equals to empty set, like this. A equals to an empty set. Okay, that means there are no elements in that set. It's empty. All right. Yes, that is basically what I thought we could now discuss in this regard, just to recap on the definitions and actually the set symbols. All right. Okay. Take care.